All right, so this week we're going to be starting our final topic of the class which is hypothesis testing. I hope everyone's excited. I'm excited. The semester's coming to an end. I think we could all use the break. So when you log into the classroom, under the 428 and 430 tab, you'll see 4 folders here. It's really important that you spend the time to watch all these folders. What I'm going to do in this lecture today, it's going to take about 20 minutes maybe, is I'm just going to give you a real brief, quick introduction to hypothesis testing. So the lecture number 1 here under the language of hypothesis testing is a really good review lecture of like the terminology I talk about in class in this Zoom lecture today. And it goes into a much deeper reasoning behind it and the deeper theory. Then I'm going to talk about a 5-step process for hypothesis testing. Now, there's 2 ways you can do hypothesis testing, and this will make more sense as we go through the lecture. There's something called the critical value approach, and there's something called the p-value approach. Either one is perfectly fine. The calculator here, all right, does the p-value approach. So I'm going to walk through the p-value approach on the calculator today. You're more than welcome to use that as you go through the, as you go through the lectures and when you get to the last exam. And then I also have here another lecture of hypothesis testing, just using a website that you're more than welcome to use. Sometimes just using a web tool is a little bit easier than your calculator. And then sometime later this week, I'll post your final week of the class, which will be, this week we'll talk about hypothesis testing for a mean or for an average. Next week, we're going to talk about hypothesis testing for a proportion. And also next week, I'll post your last exam for you. All right. Does anybody have any questions about any of that before I move on to the lecture? No questions? Okay. All right, so today's lecture is just an introduction to hypothesis testing, so our final topic. All right, so what exactly is hypothesis testing, okay? And all hypothesis testing is, it's a process to test the validity of a claim. So what we're gonna do is we're gonna make, you're gonna see in an example here, I'm gonna make some type of claim about the value of a parameter, all right? And what we wanna do is we wanna test to see if that claim is true or false, okay? So let me give you this example. This is the example we're gonna work through this lecture with, okay? So I just made this data up, so don't take this as true. But let's just imagine that I didn't make it up and it is correct. So a recent study said that on average, college students watch an average of 20 hours of television per week, okay? So that's the national average. That's every college student across the entire country, in each state. So 20 hours of TV a week. Now, some students watch more, some students watch less, whatever, that's just the average. So my question for you is this: do you think WCC students watch more or less TV on average per week than that 20 hours? I'm just curious what people think in the chat. More or less? No one wants to guess? No one wants to throw out an answer? Okay, well, I'll tell you what I think. So there's this professor here at WCC thinks that the mean hours of TV watched per week by WCC students is less than 20 hours per week, okay? So that's my claim. I'm saying, you know what? There's a lot going on with WCC students. They probably don't have all the free time in the world to be watching television. So I think that the average is less than 20. Okay, so I think the average for WCC students has gone down. So that's my claim, okay? So the thing is, when I make a claim like that, it can either be true or false, right? So I can either be correct or I can be incorrect. So what we need now is we need a method to test that claim, to see if it's true or to see if it's false, okay? And that's what hypothesis testing is. Hypothesis testing is gonna be a 5-step process to help us test the validity of this claim that I'm making. Okay. So first thing, you have to talk about how you set up a hypothesis test. And generally this is actually the hardest part for students. So if you can get this kind of to make sense, and you can set up a hypothesis test correctly, the rest of the problems just really fall into place. They're actually pretty straightforward, and your calculator can do most of the solving for us. Okay, so we got this claim. My claim here that we want to test to see is true is that the mean hours of TV watched per week by WCC students is less than 20 hours per week. All right, so because a claim can be either true or false, all right, like my claim can either be correct or incorrect, hypothesis testing is going to involve two statements. Okay, we're going to have something called H with a subscripted 0, which I'll call H naught or H0. I'll interchange that terminology. This is what we call the null hypothesis. And then there's another statement, H1, or sometimes the textbook will denote it as H sub A, but I'll always denote it as H sub 1, okay? This is what's called the alternative hypothesis. Okay, so we've got to set up these two statements. So the first statement, the null hypothesis, is you're going to have this, think of this as your starting assumption. So you're going to make some assumption with the data, all right? And this null hypothesis, this is really important, in statistics will always be a statement of equality. Okay, so we're always going to start with the assumption that what we're investigating is equal to some number. That's how we're going to start. And then this alternative hypothesis, the second statement that we're going to set up, is it's going to be a statement to be tested. All right, it's what you're looking for evidence to support this statement. So the example of hypothesis testing, why we need two statements that I think really brings it home, is the criminal justice system. Okay, so believe it or not, imagine just for fun, imagine that I'm arrested and put on trial. Okay, and I'm put in front of a jury. Okay, what is the jury instructed to assume initially when I go on trial? Can anyone put in the chat what they think the jury is instructed to assume?
That you're guilty?
I don't think so, right? Like, so our criminal justice system, you're not assumed guilty, you're assumed
innocent.
Okay, so there's a starting assumption, right? So when I'm put on trial, the null hypothesis, the starting assumption is that I am innocent. Okay, so this is my null hypothesis, that Matt is innocent. And what the district attorney or the prosecuting attorney, whoever, what they're looking to show evidence for is that I'm guilty, right? So you assume you're innocent until evidence shows that you're guilty. Okay, so that's how we're going to do hypothesis testing in this class. You're going to have some starting assumption, okay, except it's going to be some type of number. And then you're going to have some other statement here. The alternative statement is what you're looking to show, okay? All right, so we're not going to write hypothesis testing statements like this in our class. We're going to have to put numbers and notation to it. So in this class, in our statistics course, hypothesis tests will always be set up three ways. Okay, we're going to have what are called, it can either be what's called a two-tailed test, it can be called a right-tailed test, or it can be called a left-tailed test. Okay, so your null hypothesis, and this will make more sense when we get into our first example. Okay, a null hypothesis here, it's always going to be a statement of equality. So we're going to be investigating some mean. So that's the Greek letter mu, that stands for a population mean. So we're going to start, and doesn't matter the type of test, two-tailed, right-tailed, or left-tailed. The null hypothesis will always start with the mean is equal to some number, okay? So like here, we're going to have to start with some assumption, okay? What's the only number that's given in my problem here? That students watch how many hours per week? Looks like they watch 20 hours per week. So we're going to start with some null assumption there, all right? And now the alternative hypothesis you'll see is set up. We have three options. So the null is the same for each type of test here, right? The alternative is different. A two-tailed test here is that you're saying the mean is not equal to that number. And notice that mu sub 0 here, it's the same notation. It's going to be the same number. So we use two-tailed tests when we want to test to see if like the value is different or that it's changed. You could put a greater than sign, okay? We could say, all right, the mean we're investigating is greater than that number, okay? This is when you want to investigate if you want to see if things have increased or if they've gone up. a left-tailed test here, here we have that our mean is less than some number. Okay, this is when you want to test to see if I think the mean has gone down or I think the mean is decreased. So when you look at my problem here, I want to test to see that it's less than 20 hours per week, all right, that it's less than. So does that sound like a two-tailed, right-tailed, or left-tailed test? Yeah, left-tailed there in the chat. It definitely sounds like a left-tailed test. Okay, so now here's what we want to do. All right, we want to test the claim. All right, the claim that I'm going to make. All right, so to test the claim, all right, you need to have evidence. Like if we go back to how hypothesis tests are set up, okay, you're looking for evidence to support this. So in statistics, your evidence will always, always, always be sample data. Okay, so here's how a lot of these problems will look. Okay, so a recent study said that on average, college students watch an average of 20 hours of TV per week. All right, a professor at WCC thinks that the mean hours of TV watched per week by WCC students is less than 20 hours per week. Okay, so to test his claim, he randomly samples, now these are the important numbers, 31 WCC students, so that's my N, okay, that's my sample size, and finds the mean to be 18.75 hours. So of these 31 students, on average, they watch 18.75 hours of TV per week with a standard deviation of 12.25 hours, okay? So look what you're given here. You're given a sample size, you're given a sample mean, and you're given a sample standard deviation, all right? You're gonna go on, it says to test the claim at the 0.05 level of significance, okay? So what I say when I wanna test the claim is I wanna say if Matt's claim here that students watch less than 20 hours per week on average is true or false, okay? All right, so far, kind of with me on that? At least kind of what the problem is? Everybody got that sense before I go on to actually how to test my claim? Oh, okay. So here's the deal. Hypothesis testing, okay? When you go to do these tests, it's always going to be a 5-step process, okay? It's always going to be the same 5 steps, okay? The first thing you're going to do is you're going to have to set up the test. So setting up the test involves 2 things. First, you have to define what mean you're investigating, okay? So do I know on average how many hours of television nationally across the entire country that college students watch? Like, do I know the national average? I don't know, look here. What does it say the national average is? How many hours per week? 20. Okay, so that's the national average. So what I'm investigating here, what I'm looking to investigate is that WCC students watch less on average. So I'm investigating the average for WCC students. So I'm going to define this variable mu. I'm going to let mu equal the mean hours of TV watched by WCC students per week. And my claim is that I'm saying that they watch less television on average. So going back to this slide here, it sounded like that left-tailed test. Okay, so this is how you're going to write hypothesis tests. You're going to write your null hypothesis and your alternative hypothesis right on top of each other, okay? And your null is always going to be a statement of equality. And since it's a left-tailed test, we're going to say, hey, wait a second, that mean is less than some number. So your null hypothesis, your base assumption is you're going to assume at the start that WCC students watch just as many hours of TV per week as the rest of the country. So we're going to start with the assumption that WCC students watch 20 hours of TV per week. And my claim here was, wait a second, no way. Students got to watch less than 20 hours of TV per week. So what I'm looking to show is I'm looking to have this evidence to show that my alternative hypothesis is true. okay? All right, that's always going to be step one of a hypothesis test. Step two, you're going to select what's called your level of significance, okay? The good news is this will always be given for you, okay? There's going to be three common levels of significance. It's always going to be 0.01, 0.05, or 0.10. Generally, the industry standard is 0.05. So think about what the level of significance is, okay? It's actually the probability you'll commit a type 1 error, and that's covered in the lectures that I have posted to Blackboard for you. But the way I like to think about it is how often you're willing to be wrong. Really, that's basically what it means. So if you're testing at a 0.05 level of significance, what you're saying is 5% of the time I perform this test, I will make an incorrect conclusion. So we define the level of significance with this Greek letter alpha, and it'll always be given for you. Okay, step three, you need to compute what's called the test statistic. And what the test statistic is it tells you basically how many standard errors you are from the assumed mean. Now, the good news is there's a formula for this, but your calculator will compute this test statistic for you. So you're going to grab your trusty calculator right here. And for this next step, both step 3 and 4, your calculator will do for you. So what you're going to do is you're going to press the stat button. You're going to scroll over till you see tests. And always, 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 this is incredibly important. Always, 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 you want this thing called t-test right here. Number 2, option number 2. So you're going to scroll down to t-test. You're going to hit enter. And you're going to see 2 options. There's an option for data. Now what this option is when you have data, just the raw data. So I have a video posted to Blackboard showing you how to use this option data. But we want the option stats. And what stats means is when they give you the sample size, the mean, and the standard deviation for you. They just tell you that. So we're going to scroll over to stats, and we're going to hit enter. And now you're going to see all of this. Okay, so this is how you're going to handle this, plugging this in. Mu sub 0, what this means is this is the value you have put in your null hypothesis. So right here I have that the mu is equal to 20. So this is your base assumption value. So in here I'm going to put 20. X bar is your sample mean. Okay, so that is this value that on average they watched 18.75 hours of TV per week. S sub X, okay, that is your standard deviation, your sample standard deviation, so that's 12.25. And N here, that's your sample size. Okay, so that's your 31 students. All right, after you plug that in, you're gonna see these 3 options here. What you have to do is you have to change it to be equal to whatever type of test you have. So if you look in the alternative, we have this less than sign here. So you have to scroll over till you get to the less than sign right here. And you're gonna have to hit enter. And then you're just gonna, at this point, scroll down till you get to calculate. And once you're at calculate, you're just gonna hit enter. And you should see something that looks like this. I'm just curious, did anybody follow along with their graphing calculator also get this? Okay. And I also have a bunch of examples posted to Blackboard that shows, that repeats these examples for you. Okay. So your test statistic, that's this T thing up here. T is equal to negative 0.5681. This test statistic right here you will use if you're interested in learning how to do the critical value approach for hypothesis testing. What we're going to be interested in is this thing called the p-value. So next it says compute the p-value. So this is the p-value under here. P is equal to 0.287, and I'm going to round it to 1. The technical interpretation of a p-value is the following, and it's a little wordy. It's the probability you would observe at results at least as extreme as what you just did if the null hypothesis was true. Okay. Basically, for statistics, we use the p-value here and compare it with our other value up here, okay, with our level of significance. So you're just going to look at this number and this number here. Okay, so there's two types of conclusions you can make, okay? Either Matt's claim was right or Matt's claim was wrong, okay? In hypothesis testing, we call those fail to reject the null hypothesis or reject the null hypothesis. And this is all you need to remember, and this is also in the lecture slides posted to Blackboard. When the p-value here is greater than the level of significance, which it is, okay, so because our p-value is greater than the level of significance. So what we're seeing here is that this value 0.2871 is greater than 0.05, okay? We do what's called, we fail to reject the null hypothesis. Okay, what that means here is evidence does not support the alternative hypothesis. When I'm saying evidence doesn't support the alternative hypothesis, it's like saying the person is not guilty. So what we're saying is I cannot conclude that this is not true. So even though the sample mean came back as 18.75, it was really only from 31 students. So it wasn't far enough away to say that there was evidence to support that for sure WCC students watch less TV on average. So it looks like, according to just this made up study that I did here, that you guys watch 20 hours of TV on average, just like every other college student. All right. Now, if this p-value had been less than this number, you would reject the null. And there's examples of this in the online lectures. And what you would say is evidence supports the alternative hypothesis. All right, now I know this was a real quick, literally 20-minute kind of walk through the process. But do you think you guys would be able to handle some of these on your own this week? All right, well, at the very least, here's what you should do after this lecture, okay? Go into Blackboard. Under the tab 428 and 430, watch all of these videos. They probably total an hour to watch them all. Okay, that's not that much time, all right? After you try watching all 4 videos, if you go to the discussion board, I have this practice problem here, and you should give both of them a try, okay? And what I'll do is once you give them a shot, I will respond and let you know if you did it right or wrong, okay? Does that sound okay with everybody? All right, I'll stop the recording now.